Okay, solving quadratics. I guess review 2. This time we're going to solve, and we're going to solve these quadratics by using the factoring technique, difference of two perfect squares. Okay, again, the process, as you can see from review 1, is the same. When we're factoring, or when we're solving something in which you have an x squared, you have to factor. So our goal is to get 0 on one side. Then after we get 0 on one side, we want to factor. In this case, since we're dealing with the difference of two perfect squares, that's going to be the factoring technique we're going to use to break up the x squared term. And then we're going to set each factor equal to 0 and solve, just like we did before. All right, so we come to our question, we're solving, we see the x squared, we have to get 0 on one side, so that's been done for us. There is no greatest common factor, so now we go to difference of two perfect squares, and that's exactly what this is, because you can take the square root of both terms, and the difference means we're subtracting. So by definition, the difference of two perfect squares factors into two binomials. The square root of the positive term is what comes first. X squared is the positive term, so we get x and x. Your signs are going to be different. And then the negative term, or the term that follows the subtraction sign, which is 49, its square root comes second. It's 7 and 7. All right, so now it is factored. So we got 0 on one side. We did factor. Now set each factor equal to 0. We get x plus 7 is equal to 0. We get x minus 7 is equal to 0. And then we solve. Over here, I'm going to subtract 7 from both sides. And I get x equals a negative 7. Over here, I'm going to add 7 to both sides. And we get x is equal to 7. And we're done. Next question. And again, I just wrote over it, so let's make sure we're okay with this. This is a squared equals 64. All right, and we're looking to solve for this one. So once again, we are going to try to solve this by, you see the a squared, so we're going to have to factor it. So before we can factor it, we have to get 0 on one side, so we're going to have to do that. In this case, again, if the squared term is positive, leave it alone and bring everything else over to it. So I'm going to subtract 64 from both sides, and I'm left with a squared minus 64 is equal to 0. All right, so I got the 0 on one side. Now I'm going to factor it. All right, again, look for the GCF. There isn't any. Now look for difference of two perfect squares. That's exactly what this is. So by definition, that's going to break up into two binomials. The signs are going to be different. The positive term is the a squared term. Its square root comes first. The square root of a squared is a. The 64 follows the minus sign, so it's going to come second in each binomial. The square root of 64 is 8. So it's factored. We'll bring this over here so you can see it. I'm going to take each factor, x plus 8, and set it equal to 0. And not x, in this case a minus 8, and set it equal to 0. Over here, just simply subtract 8 from both sides. A is equal to a negative 8. Over here, I'm going to add 8 to both sides. A is equal to a positive 8. Okay? And you have 3 to try on your own. First one, well, the first two kind of match up with the two examples here. Example 3, this one involves a, first of all, you see an x cubed, which means you can have 3 possible answers. And the hint is to use GCF first and then difference of two perfect squares. Good luck with that one.